everyone, welcome to Properties of Logs and Exponents. Here is just a quick review of all of these properties. I have them all down here so that way you can see them, and they will be useful. It's also on that DA 5.7 worksheet, so that way if you get confused or lost, you can always look at those again. Alright, so let's just go and do some examples here. So it's r to the m plus n. And you say, okay, so I look at some of these properties and say, m plus n. Oh, there we go. So maybe I can rewrite it with this law of exponents right here. Yes, we could. You can say this is r to the m times r to the n. There you go. That's the first one. Okay, good. So now we have the next one, log of t plus log of q. So I'm looking probably at these logs over here, and I'm looking for log of t plus log of q. Oh, it looks like this first one right here. And so I have this right side, I won't be able to write this left side. So really it's just a times b. So I can rewrite this as log of t times q. There we go, close my parentheses, and we've got it. Alright, so far so good. Now I'm looking at this one, log of m over n. If I look at m over n, I look at this second column, or second row, log of a over b equals log of a minus log of b. So it's kind of like what we just did up here, but backwards. So it's going to be log of m minus log of n. You can kind of remember division kind of changes to subtraction. Alright, but remember we have one log here where we have two logs here. So when I change this stuff up, it's going to be log of m minus log of n. Alright, and this one, last one we have right here is the pth root of x to the n. So I say x to the n, pth root, and is it any of this stuff over here? I don't really see it, but could we maybe write this in a different way? If I have the pth root, I can say this is x to the n to the 1 over p. Okay, so now it can look like this exponential law of exponents right here. So that means we can write this as x to the n over p. And there you go, there would be our answer. So this p, because it's a root, changes to 1 over p, and then we can just multiply them together, and that's just as easy as saying n over p. Alright, so now here's what you're going to do. Please tell me the following. What is s to the t plus r? S to the t times s to the r. Okay, question 2. Log of m minus log of z. That's going to be log of m divided by z. Question 3. Log of m times n. That is log of m plus log of n. And question 4. W to the 9th times w to the 4th. That's w to the 9 plus 4, which is w to the 13. There you go. Okay, now let's do this next example. We're actually going to be solving some equations. I've got 4 times 2.7 to the x equals 947. Alright, so solving this is going to be exactly the same steps as you solve a linear equation or any other equation we've been solving for years and years and years. The first thing I'm going to do is I want to get the x all by itself, so I'm going to try and get rid of that 4. So I'm going to divide by 4, and I get 2.7 to the x equals. And let's just figure out what that equals. Oh, quit. And we got 947 divided by 4, and that is 236.75. See? Perfect. Okay, so now I've got 2.7 to the x equals that number. That's helpful, but not as helpful as being able to say x equals something. So I want to be able to rewrite this whole thing. How do I do that? Well, if you remember, if you know anything about logs, we are going to use logs. So I want to be able to say this is my base of this number equals x. So I'm going to go from here to here and back around. That's how we can rewrite log. So I can say log base 2.7 of 236.75 equals x. And now all I have to do is figure out what is that thing. The nice part is your calculator comes with some change of base formula already in it. If you go to math, you want to go down to right here, A. So if it says log base, all I have to do is type in my numbers. 2.7, and then it's going to be of 236.75. And I get 5.504. So I can say 5.504 is about equal to x. All right, very good. So now what I'm going to ask you to do is right here, you may not have that change of base, you may not have that calculator, but I want you to rewrite this using logs. That way you should end up with x equals something. What does x equal? Log base that of this equals x. So I can say x equals log base 1.25 of 19. I'll write it down here because it's kind of hard to see. I'm going to say x equals log base 1.25 of 19. And you say, but Mr. Barman, the last time you did this, you wrote it over here. Does it matter which side the x is on? Of course not. So if you want to write x equals or the log of this stuff equals x, either way is going to be fine. All right? So, very good. That is properties of logs and exponents.